Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 30. And this problem asks us to draw the structure and give the IUPAC names for all carboxylic acids having a molecular formula of C5. So we have C5H10O2. And then give the IUPAC names for the sodium salts that results from treatment with sodium hydroxide. So it's asking us to draw all the isomers that have carboxylic acid and this molecular formula. So the most simple one is a straight chain. So we have 5 carbons. So here we have 1, 2, 3, 4, 5. Next, we can draw now 4 carbons. So 1, 2, 3, 4. And then a carbon coming up from this position here. Alternatively, we can have the same 4 carbons, but the methyl group from here. So we can draw that one. 1, 2, 3, 4. Methyl coming out here. Alternatively, we can have only 3 carbons and then 2 methyls coming out of the same carbon. So 1, 2, 3. And we have these two. So I think this is all the different isomers that can exist. So now let's name this. So if we name this first one, so the longest parent chain is pentane. So we have 5 carbons. So pentane, but it's a carboxylic acid, so we add the suffix oic acid. So we have pentanoic acid for this one. Now for the second one, now we have 4 carbons long, so it's a butanoic acid. And on carbon 1, 2, 3, remember counting carbon 1 as the carbon with the carboxylic acid. Carbon 3, we have a methyl group. 3-methyl butanoic acid. Next, we also have a butanoic acid. But now the methyl group is on carbon 2, so we have a 2-methyl butanoic acid. Last but not least, we have now only 3 carbons as the parent chain. So we have propanoic acid. And then we have a 2,2-dimethyl propanoic acid. So what happens once we deprotonate these? Well, we're going to form the conjugate base. So we treat them with a strong base such as sodium hydroxide. We are going to deprotonate the most acidic proton, being the proton on the carboxylic acid, to give us the conjugate base for each of these molecules. So I'll draw those out. And it asks us to now name these as well. So now we have a negative charge, we have the conjugate base, but this would not exist in solution alone. We would have some sort of metal salt conjugating next to it or through electrostatic interaction. So the question asks us that we have sodium salts that are going to electrostatically interact with these conjugate bases to help neutralize them and increase their stability. And now in terms of naming, so these will have the exact same names, but now the only difference is these are no longer the acid. These are the conjugate bases. So they won't any longer have the suffix oic acid. They're going to have the suffix ate. So we have a pentanoate, but specifically we have a sodium pentanoate. So the metal ion must come first. So we have a sodium pentanoate. For this one, we have a 3-methyl butanoate. Remember, it's no longer an acid form. It's in its conjugate base form, but it's in its sodium salt. So we have a sodium 3-methyl butanoate. The third one, 2-methyl butanoate and sodium. And last but not least, You have a 2,2-dimethylpropanoate, but a sodium salt of this.